Great, so we're going to finish up the 1.8 notes. This would technically be 1.8b because we're going to take a look at the second page of this packet of notes here. So some word problems. The sun is at an angle over the horizon of 35 degrees. Tom is casting a shadow that's 8 feet long. We don't know how tall Tom is. So I draw a picture. We've got the sun over here. The sun has some beams that go down to the horizon, and in the triangle that we want, this is it. The angle right here at 35 degrees. We've got Tom standing somewhere along here. Tom's going to be, let's throw Tom right here. Tom's got a shadow that's 8 feet long. Well, think about where the sun is in relation to Tom, where his shadow would be. Tom's shadow is going to be right here along the ground. His shadow is 8 feet long. So we're going to go to the end of his shadow, which would be out here, which this is a ridiculously long shadow for Tom, but this is 8 feet right here. And we want to know how tall is Tom. So that's what we want to know is X. How tall is he? And so I've got a nice triangle with a couple of things that are filled in. I only need to find that opposite side, and I have the adjacent side. So opposite and adjacent reminds me of tangent. So I do tangent of 35 is equal to the opposite over the adjacent, multiplied by 8 on both sides to get rid of the fraction. And I get 8 times tangent of 35 is equal to x. When I actually multiply that out, I get that Tom is 5.6 feet tall. He is not 5 foot 6 inches. Okay, he is 5.6 feet tall. 5.5 would be 5 foot 6. And I'm okay with you leaving it as 5.6 feet. It just asks how tall he is. It doesn't ask for in feet or to have to make that conversion in there. Example 6, a stairway is being built for a house. It has a run of 8 feet and a rise of 6 feet 8 inches. What is the angle of inclination of the stairs? So I've got a nice little stair set here. Stairs kind of look like this. Whoa, those are bad stairs at the top. You're gonna fall off there. There we go. So we've got a run of 8 feet. So from the beginning of the stairs to the end, we've got 8 feet. And the stairs have a rise here of 6 feet 8 inches. What is the angle of inclination? So in this set of stairs, we're looking for this here. With angles, I'm going to put theta, but you can put an x there if you wanted to, and that would be fine. The first thing that I see is that I have 8 feet and 6 feet 8 inches. So I either need to turn these all into inches or I need to turn them all into feet. Okay, it doesn't really matter. I think we're pretty comfortable changing these things into feet, from feet to inches. And so I've got 8 feet. 8 feet in inches is just taking 12 times 8, which gives me 96 inches. On this side, I've got 8 inches in addition to my 6 feet. So I do 6 times 12, which is 72, plus my 8 inches, and this is 80 inches. So I've got 96 inches and 80 inches. We want to know the angle of inclination. So I've got an opposite side and an adjacent side. Opposite over adjacent again reminds me of tangent. So I've got the tangent of theta is equal to the opposite, which was 80 inches, divided by the adjacent, which was 96 inches. Now this is again where where this section becomes different than the other sections that we did before. I want to get rid of the tangent on this side so that I can figure out what theta is. That's what my question is. So I'm going to take the inverse tangent, and I'm going to take the inverse tangent over here of 80 over 96. On the left side, the tangents are going to cancel out, and it gives me just theta. On the right-hand side, I actually have to do that on my calculator unless you know what the inverse tangent of 80 over 96 is. Don't do the 80 divided by 96. and then take the inverse tangent of it, actually do the inverse tangent of 80 divided by 96. So I get 39.81, and we'll round to hundredths. It doesn't specify, but 39.81 degrees would be my inclination of my stairs. And then finally, example 7, we have a lighthouse out here. Oh, this is going to be a good drawing. A lighthouse kind of has a peak at the top, kind of a round. It has a light in the middle that shines out. There's a lighthouse. I should go pick a picture out. There's a lighthouse. Spots 2 ships. They're out at sea. One has an angle of depression of 20 degrees. So one ship that it sees out here, it has a 20-degree angle here. And the other has an angle of 30 degrees. So an angle of 30 degrees actually means that this boat is going to be a little bit farther out here. So this angle right here, that huge angle, the big angle, is 30 degrees. If the lighthouse is 250 feet off the ground, how far apart are the boats? So this is 250 feet off here. I want to know how far away that boat is, and how far away this boat is. So really I've got 2 triangles in here. I'm looking for 2 different things. And so it would be best if I were to just create those 2 triangles. So when I look at this, I've got triangle number 1, looks like this, with a 30-degree angle here. And I'm looking for this, with 250 over here. And triangle number 2 looks like this, with 250 over here. I'm looking for this with an angle of 20 degrees. So the first one, I'm looking for the opposite side, and I have the adjacent side. So again, I'm looking at tangent here. So I've got tangent of 30 equals x over 250. Multiply by 250, I get x equals 250 of tan 30. Now there's a lot of ways that you can do this. If you remember what the tangent of 30 was, you can just use the fact that the tangent of 30 was the square root of 3 over 3. But if you don't remember that, then go ahead and just use the decimal. Take 250 times the tangent of 30, and I'm okay with that too. You get 144.34. We're talking in feet here. The lighthouse was in feet, so this is going to be in feet as well. So the first boat is that far away from the lighthouse. The second boat, I have the same exact information, except it's tangent of 20 degrees instead of tangent of 30 degrees, equals y over 250 multiplied by 250. So I've got 250 times the tangent of 20 degrees this time. Gives me that y is equal to 90.99 feet. Neither one of those things actually answer the question though. The question is, how far apart are the boats? So if this is 90.99 and this one is 144.34, the difference in between them is 144.34 minus 90.99. So they are the boats are 53.35 feet away from each other. Now, it doesn't really seem like they would be that far away, but we're looking at different angles of inclination, and 53 feet is actually pretty close for 2 boats, but if one is parked and the other one is coming into port, it's not really that big a deal. So keep in mind that that 53 feet really isn't super far away for two monster boats if they're actually coming in and need a lighthouse. But that's where the problem goes, and it asks us for how far away they are. That's the actual answer. It's not either one of the individual boats by themselves. So this this work that we just did is for this assignment. And so when you do taking the quiz, this is the place that the quiz is going to come from. So make sure you go through, do the assignment from the book, and ask if you have any questions along the way. Draw a picture. Make it a good picture. Better than mine.